Okay, this is A2Further Pure Maths. We are on Unit 8 and we're towards the very end of it. So this is example 3 on the last section. Let's take a wee look then. So use a substitution x equals 3 upon 1 plus sine t to evaluate the integral between 4.5 and 3 of 1 over 6x minus x squared to the power of a half dx for x equals 3 plus 3 sine t, and dx by dt is 3 cos t. Goodness. So as it says, in x is 3 upon 1 plus sine t, that we've written there. If you want, then x equals 3 plus 3 sine t, and dx by dt would give us then 3 cos t. 6x minus x squared is going to be what then? It's going to be 6 times this here, so that's going to be 18 plus 18 sine t. And then whenever you're squaring this, so I'm just going to square this one here, it's going to be minus 9 upon 1 plus sine t squared. Now if you multiply this all out and start to tidy it up, things do tidy a wee bit. So we have minus 9 upon 1 plus sine t all squared. It gives me 1 plus 2 sine t plus sine squared t. So it's going to be minus 9 and then minus 18 sine t, so it actually cancels out there, and then the 18 and the minus 9 cancel, so you actually end up with 9 upon 1 minus sine squared t. How does that help us? Well, 6x minus x squared, then it's going to be 9 cos squared t. So that means this bit up here, which is this in the square root of that, therefore 6x minus x squared to the power of a half is going to be 3 cos t. So when x equals 3, sine t equals 0, and it gives us t is 0, so that's that bottom integral then. Whenever x is 4.5, sine t, if you think about that, 1.5 through 1.5 then dividing in by 3, you only get a half, so sine t is a half, and that means the value of t then is pi over 6. I hope you see what I've done there. So I'm changing my units here from x into t, so whenever I do integrate this I don't need to change it back into the right format. So that's where we are there. That means hence the integral 4.5 and 3, 1 over 6x minus x squared all to the power of a half dx is actually the same as the integral between pi over 6 and 0, 1 over 6x minus x squared all to the power of a half dx by dt. That equals the integral between pi over 6, need to keep remembering to move this up, and 0, 1 over 3 cos t, and that's upon 3 cos t, because that's what our dx by dt is, remember, dt. So finally things have tidied up significantly. Pi over 6 and 0 of 1 dt, and that of course then just gives us pi over 6. So after all that, I just have a wee comment in the right here. So it said, I've just written, you, just add this to your notes, will often need integration by parts to find integrals of inverse trig functions or hyperbolic functions as well. Time, doing okay. Example 4. Use integration by parts to find the integral of r sine x dx. So what do we know? We already know d by dx of r sine x, and that's 1 over the square root of 1 plus x squared. Again, you can kind of look back and see that from previous stuff. So using parts for the integral of r sine x dx, I'm of course going to let u equal r sine x, and then let dv by dx equals 1. Give me a wee second. So we have that. That means then du by dx is going to be 1 over the square root of 1 plus x squared, and then v is going to be the integral of that, is going to be x. So the integral then of r sine x equals uv, so it's x r sine x. Take away v du by dx, so it's x all over the square root of 1 plus x squared dx. You can see that we're not quite there yet, so we need to try and work out how we're going to do this one. So we're going to let t squared equal to 1 plus x squared. We're going to differentiate this, so we do it implicitly. We'll get 2t dt by dx gives me 2x. So it means then dt by dx is x over t, and x dx by dt then equals t. So this bit here, the integral then of x square root of 1 minus x squared dx, 1 plus x squared, sorry, is going to equal the integral of x over t squared. You see what I've done there? Because I've let 1 plus x squared equal my t squared, times dx by dt, dt, so that's quite nice. Dx by dt then is going to be t over x, so I will have, so the square root of t squared is just t multiplied by t dt. That gives me a 1. That gives me then t plus c. So if you're still with me, therefore the integral of r sine x dx equals the uv bit, which is x r sine x, minus t plus c, and change it back in, then it's going to be x r sine x minus the square root of 1 plus x squared plus c. Fairly tough one there with a couple of different moves. We've used integration by parts to start with, and then we've used the substitution t squared equals 1 plus x squared. Again, all comes with a wee bit of practice. Final example then, example 5. Given your answer to 3 Newman figures, find the area of the region bounded by the curve with the equation y equals r tangent x. The x-axis and the line x equals a half. So what are we trying to find? We're trying to find the area, which is the integral between a half and 0 of of r tangent x dx. Again, we can use the fact that we know how to differentiate this to make life a little bit easier if we use our integration by parts. So by parts again, if we let u equal r tangent x and then dv by dx equals 1, du by dx is 1 over 1 minus x squared, and then our v equals x. So where are we? Area equals uv, this times this, so it's x r tangent x, and that's between 1/2 and 0. Take away the integral between 1/2 and 0 of x over 1 minus x squared dx. That equals then a x r tangent x between 1/2 and 0 minus, finally we've got something we can do after all this 1 minus x squared and things like that. If you differentiate the bottom line, you get minus 2x, which is a bit like the top line, so it's going to be a nice easy ln one for us. I hope we're okay with that. So it's minus 1/2, we need to take out the front, so that changes this bit then to a plus 1/2 ln 1 minus x squared between 1/2 and 0. Where's that wee letter then? Plus c. I think that's right, isn't it? So we have then 1/2, putting our 1/2 in here, or times 1/2, of course, plus put in our 1/2 here, minus 1/4, so 1/2 ln 3/4 minus 1/2 ln 1. We're asked for the 3 significant figures, so it's 0.2747. You put that bit into your calculator, minus 0.1438, and that gives us then 0.131. That's the 3 significant figures.